So I wanted to give you the Graphing Rational Functions Worksheet answer key. And I wanted to show you how to do any of these problems that you might have questions with. I know I've been in touch with some of you more than others, so the live answer key is right here. You can see I factored the top and the bottom. These canceled out, so actually this produces a whole at -5, -6, I think 6 if I plug that in. I'm doing that in my head. But it's not asking for a whole, so it doesn't even really matter. To find the vertical asymptote, you're looking at for what's left on the bottom, what would create a 0 on the bottom. And the horizontal asymptote, because their degrees are equal, it's 1/1, which is just 1. Number 2, I factored. When you go to factor, there you have the x plus 3 and the x plus 3, which cancel, which means there's actually a whole at -3, -6, I believe, off the top of my head, plugging it back in. Doesn't matter, didn't ask. There's no vertical asymptote left on the bottom. And the horizontal asymptote, because the numerator's degree is bigger, there is none. And lastly on this one, you can see I haven't done it yet, but this one's going to factor 2x squared plus 12x minus 3x minus 6. So I have 2x minus 3 times x plus 6. Let me make sure I did my work right. 2x squared minus 3. Yep, that works. These guys will cancel. That's a whole. Not asking, just saying. Vertical asymptote is at x equals 3/2. And the horizontal asymptote, because the degree in the denominator is bigger, is at y equals 0. Okay, going over to these problems. Same concept, there's just more going on. Vertical asymptote. Denominator. There are no holes. The x-intercept is when you plug. What am I doing? Oh boy, I just made a mistake. You can't catch me on it though, because thankfully no one's here to yell at me. I always do the y-intercept first. It's when x equals 0. So when you plug 0 in here, you get 3/2. And what would produce a 0 there? Would anything produce a 0 there? Plug 0 in. If this were a 0, see, I have to do this out because I haven't really woken up yet. When y is 0, you'd multiply, and nothing's going to happen here. There just is none. And the horizontal asymptote, oh, I see why. Because what's the horizontal asymptote? The degree on the bottom is bigger. So that's why there is no x-intercept. So when we go to graph, I'm just going to graph the few things that I have right now. Should I do this? I'm going to try to do this in a marker. Hold on. There I go. So just to make it a little darker, that's my vertical asymptote. And I have my horizontal asymptote. So I have that. And then what I'm looking for, I have a y-intercept at 0, 3/2, which is about there. Okay. And let's see what happens. You know it's going to somehow do this. That's the assumption. It's usually going to hug the asymptotes. We've heard them say that. It just follows it. But I still like to put numbers in because it makes me feel better about things. Some of you may not use that approach, but when I plug -1 in, -1 plus 2 is 1, so you'd get 3. So it's going to make sense. It's going to start to hug that. So I just kind of like that for a little verification that that's the direction that that part of the graph is heading in. And then as I get closer this way, I'm just going to plug in. I can plug in positive. What do I want to plug in? I guess I can plug in. Let's plug in 2 for x. So I get 3/4. Which is approximately there. So it's just going to hug the asymptote. So that's what's going to happen on that problem. On the other side of the graph, I'm going to plug in a -4. When I plug in -4, I get negative 4 plus 2 is negative 2, negative 1.5. So 1, 2, 3, 4, approximately there. And once again, the behavior is going to hug the asymptotes. So if you like a little more verification, plug something a little more to the left of that. And plug something a little more to the right. I can't do that. That's my asymptote. That would be silly. So when I plug negative 3 in, I get negative 3 plus 2 is negative 1. So I get this. So once again, it's going to do this kind of thing. That's what your graph should look like. I'm going to take a break of talking right now, and I will plug the answer for number 5 in on Google Classroom as a picture. Bye.